Assalamualaikum and hi, my name is Muhammad Afif Nurhan. Today I would like to present about introduction of conduction on heat transfer. Okay, for the first point, conduction heat transfer is the transfer of heat through metals such as solid, liquid and gas without bulk motion of the metal. Besides, conduction is the transfer of energy from the more energetic to less energetic particle of the substance due to interaction between the particle. For the second point is conduction occur when a substance is heated particle will gain more energy and vibrate more. This molecule then bump into nearby particle and transfer some of their energy to them. Furthermore, continue and pass the energy from the hot and down to the cool end of the substance. For the last point is heat transfer in solid is due to the combination of lattice vibration of the molecule and the energy transferred by a free electron. Consider steady state heat transfer through the wall of an altar with thickness where the wall inside the altar is higher temperature compared with the outside wall.
Hi, I am Wafa Izati. We'll be explaining about the designs of a surface that we create for this group assignment. So for design 1, the blue color is the fan surface, while the yellow color is the chip that we attach the fan surface to that chip. So the area is 40 times 40 millimeter, height 45 millimeter, and the fin amount of this design 1 is 169. This is the detailed dimension for design 1. So next is design 2, where the area and height is still same like design 1, which is 40 times 40 millimeter and 45 millimeter. But in design 2, we reduce the fin amount, which is only 64. This is the detailed dimension about design 2. So next, the material. Material that we use for both design is aluminium 1060 alloy. We use this aluminium because it is the most common material in heat sinks. In particular, extruded aluminium heat sinks fit the needs of most projects. This metal is lightweight and has relatively good thermal conductivity, good corrosion resistance, low density, strength at raise, formability, and make aluminium an ideal material for the construction of these heat exchangers. That's all from me. Thank you.
Assalamualaikum and hi, my name is Alifaikal bin Raslan and today I'm going to present about analysis simulation for design 1 and design 2. First one, we look at the heat, power and convection coefficient. In this case, for design 1 and design 2, we are using the same material which is aluminium. So it will have the same heat power and convection coefficient values. For the first one, heat power, we use 65 watt. This is because after doing some research, we found that standard CPU use between 65 to 85 watt. Second one, convection coefficient. We are using 63 watt per meter cube Kelvin. We found that on the internet, the heat transfer coefficient for aluminium is between 59 to 64. And the last one, result of the simulation. We can see that design 1 have the temperature range between 47.7 degrees Celsius to 61.9 degree. Meanwhile, the design 2, we get 73.3 to 104 temperature range. We can see that design 1 is better than design 2 because it have lower temperature range. The range in design 1 also is in the acceptable range for a CPU. Thank you.
Assalamualaikum and hi, my name is Siti Masbah binti Kalana. Today I will present about the discussion. As you can see, design 1 contain 169 fin with distance 3 mm. The lower temperature because has more fin, also the more heat removal. The smaller the distance between fin, the higher the effectiveness will be. At design 2, we can see there contain 64 fin with distance 5 mm. The higher temperature because more heat remain in sink. The bigger the distance between fin, the lower the effectiveness and the efficiency of fin. Besides that, we can lower the temperature by increasing the length and surface area. Also, heat transfer from a surface is increasing by adding more fin. If fin have an extremely high thermal conductivity, then the surface temperature will be equal to that of the body. Then the fin efficiency is the ratio between the fin actual removed heat with the amount of heat that is able to be removed if the whole fin has the same temperature as the temperature of fin base. Thus, the greater the value of the convective heat transfer coefficient, the smaller fin efficiency, as also happened with the fin effectivity. Also, the fin material effect on the fin efficiency and effectivity. Last but not least, the rate of heat transfer is inversely proportional to the thickness of the fin. The thicker that the insulation is, the lower the rate of the heat transfer. Thank you.
For the conclusion, the best design of conduction heat transfer is design 1. This is because the structure of design 1 are made of more fin compared to design 2, which the result increased efficiency of conduction heat transfer as it can transfer heat more faster between each fin, and that will make the temperature easily become lower to the range of 50.8 Celsius to 65.1 Celsius. Other than that, the design are suitable to be used for the product due to more fin are surface that extend for an object to increase the rate of heat transfer to the environment by increasing convection. The amount of conduction or convection of an object determines the amount of heat transfer. For the last point, design 1 is also more suitable for using value H63 heat transfer coefficient as it uses aluminum alloy material. Okay, that's all for my group. Thank you.